Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we're gonna learn about the definition of vector field and gradient vector field. What is a vector field? A vector field on 2 or 3-dimensional space is a function f that assigns to each point xy or xyz a 2 or 3-dimensional vector given by fxy or fxyz. The equation that is commonly used is fxy is equal to mxyi plus nxyj for 2-dimensional or 2 variables. For the 3-dimensional or the 3 variables is written by fxyz is equal to mxyzi plus nxyj plus pxyzk. Then, if f is a scalar function of 2 variables, then its gradient vector field on 2-dimensional space is written by this symbol is called nabla. Nabla f xy is equal to f xyi differentiate the function with respect to x for the I plus fy xyj. The j part is differentiate respected to y. And then if f is a scalar function of 3 variables, then its gradient vector field on 3-dimensional space is nabla f xyz equal to f x xyzi plus fy xyzj plus fz xyzk. For the I section is differentiate respect to x, and for the j section is differentiate respect to the y, and for the k section is differentiate respect to the z. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afif bin Ahmad. I will continue about sketching the vector field. Okay, first we need to know that the I in the function indicates the vector in the x direction, and the j in the function indicates the vector in the y direction. Okay, the equation that we choose for this assignment is fxy equal to yi minus xj. And then we determine the coordinate of the vector on the xy plane. We have selected some coordinate based on the picture shows. Okay, then we insert the coordinate into the function, and then we got the direction of the vector of each coordinate. If I is positive, then the vector is on the right direction, and if I is negative, the direction is on the left direction. Okay, and then if j is positive, the vector is going up, and if j is negative, the vector is going down on the y axis. Okay, next we sketch the vector fields on the xy plane as can be seen on the picture. The vector that we got from this equation is rotation on the clockwise direction. Okay. We also use Desmos vector field plotter to get significantly more points plotted. An example of engineering application for this type of function and sketching is during analyzing major storm system, including hurricanes and cyclone. In northern hemisphere, storms rotate counterclockwise, while in the southern hemisphere, storms rotate clockwise.
Assalamualaikum. My name is Muhammad Nur Shami. Today I'm going to show the example question of the gradient vector field. Okay, as shown, the question is function of x, y, z equal to 3x square square root of y plus cos 3z. Okay, in the step 1, I change the square root of y to the y to the power of 1 over 2 to make it easy when we differentiate it. Okay, in this function, it has 3 variables, so we need to use this formula. Okay, in the step 2, I separate the constant value first. Okay, for the x direction, the constant value is 3y to the power of 1 over 2, and for the y direction, the constant value is 3x squared. Okay, in the step 3, I will show how to differentiate the x, y, and z variables. Okay, for the x variable, it will become after we differentiate it, it will become 2x to the power of 2 minus 1, and for the y variable, after we differentiate it, it will become 1 over 2 y to the power of 1 over 2 minus 1, and for the z variable, it will become minus sine 3z times 3. Okay, in the step 4, after we differentiate it, it will get 6y to the power of 1 over 2xi plus 3 over 2x squared y to the power of minus 1 over 2j minus 3 sine 3zk. Okay, for the last step, the last equation of this equation, we will get 6x square root of yi plus 3 over 2 times x square over square root of yj minus 3 sine 3zk. Okay, there are a few examples of engineering application of the gradient vector fields, which are apparent wind in sailing and the motion of the roller coaster.
Example question for the vector field is compute the gradient vector for function of x, y, z equal to z square exponent power of x square plus 4y plus ln in bracket xy over z. The first step, we need to differentiate. To get the I, we need to differentiate the function respect to x, and the answer is 2x z square exponent power of x square plus 4y plus 1 over xy over z multiply y over z. Next, to get the j, we need to differentiate the function respect to y, and the answer is 4z square exponent power of x square plus 4y plus 1 over xy over z multiply x over z. Lastly, to get the k, we need to differentiate the function respect to z, and the answer is 2z exponent power of x square plus 4y plus 1 over xy over z multiply negative xy over z. Second step, we need to simplifying. The answer is nabla f x y z equal to 2xz square exponent power of x square plus 4y plus 1 over x I plus 4z square exponent power of x square plus 4y plus 1 over y j plus 2z exponent power of x square plus 4y negative 1 over z k. Lastly, in the step 3 is the final answer that need to return as shown in the example. Arigato, arigato.